today we're going to talk about speed and velocity. Yesterday we talked about distance and displacement, so we're going to review those a little bit. We have distance, displacement. Who can tell me the definition of a distance? All right, Johnny? Good job, exactly. So we can measure how far we've traveled, and distance is just that. It's the measure of how far we've traveled total, the total distance. Whereas displacement, what's the difference between distance and displacement? Brittany? Yeah, awesome. So displacement, that has to do with how far the ending point is from the starting point. Okay, so we're going to do a quick example problem. So if I drive 2 blocks west to get to the store, and then I drive home, what's the distance that I've traveled? Good job. We've got 4 blocks. 2 blocks there, 2 blocks back, 4 blocks total. But what's my total displacement? 0, perfect. Yeah, because my starting point and my ending point are the exact same. Even though I traveled a certain distance away, I came back to the same location. So the distance between my final point and my starting point is 0. Okay, so what instances of speed do we see every day? Go ahead, just shout them out. Any ideas you got? Great, awesome. Speedometers. Gotta love them. Speed limits. Yeah, we don't really like speed limits. Yeah. Okay, so how do we measure that? How do we measure speed? You know, you look on your speedometer, it's just the number there, but what does it really mean? So look at this problem. If it takes me 2 seconds to travel 10 meters, how many meters per second, in other words, how fast am I going? How many meters per second am I traveling? So if I want meters per second, we just have to take our 10 meters. And in physics, typically we're going to write meters as just an M. So just to kind of keep things simple. So 10 meters. And we're going to just divide that by the 2 seconds. So that gives me 5 meters per second. But does that give me a direction at all? In this problem, did I tell you what direction I was traveling? Did it matter to give me the speed? You're right, it didn't. Okay, so we're going to come back to that again. Okay, another example for speed. It takes me 10 minutes to drive 2 miles west and then drive home. So what's the total distance we've traveled? Great, 4 miles. Okay, but so how are we going to calculate our average speed? Well, we talked about in the last problem, you just have to take your total distance that you've traveled and divide it by the time that it takes you to travel that distance. So that's what that equation looks like. Speed equals total distance over total time. So let's go ahead and do that with your partners, and we will talk about it in a second. Okay, so if we want to calculate the average speed, we're going to take our total distance. Well, the total distance here is 2 miles. And how long did it take for us to travel that distance? It took us 10 minutes. So divide that by the 10 minutes, and we calculate it out, and what did you guys get? Awesome, 0.2 miles per minute. So the units on that, that's just miles per minute. Those are the units that we started with, those are we're going to end with. Okay, so now we're going to talk about velocity a little bit. This is the same problem as we did before. It takes me 10 minutes to drive 2 miles west. But now we're going to start talking about direction. What is the direction of my speed? Johnny, what's the direction? Right, west. Takes me 2 miles, drive west initially, right? But then I turn around and then I come home, so then I'm driving the opposite direction. So we're going to go back to our idea of distance and displacement that we talked about yesterday. What is my net displacement? Brittany, what's my net displacement? 0, perfect. So we've talked about a direction, and here we were able to calculate our average speed, right? But that didn't indicate the direction at all. So now we're going to talk about average velocity. So average velocity, it's really similar to speed, but rather than taking the total distance over the total time, now we're going to take the net displacement over the total time. And we'll sometimes write that as the delta x over delta t. So that delta, that little triangle thing, that's basically just saying the difference between my final point and my ending point. So delta x, that just equals x final, so the final position, minus the starting position. Basically, what's the difference? And then the same thing for the time. So how are we going to do this? What is my delta t for the total round trip? Awesome, 20 minutes. Okay, but what about my delta t? What's my net displacement? Right, it's 0. So my average velocity is 0 miles per minute because I started and ended in the same spot. So velocity is what we call a vector. You've probably talked about this in your math class. We're going to review it really quick. Whereas speed is a scalar. Speed is just a number, right? You look at your speedometer, it's just a number. It doesn't tell you that you're traveling 45 miles per hour west. It just says 45 miles per hour. The speed limit just says 50 miles per hour. It doesn't say you have to be going 50 miles per hour south. It could cause problems. Okay, so we're going to talk about vectors. Vectors have two characteristics. This is on your handout. Magnitude and direction. So magnitude, that's like my 45 miles an hour, and the direction. What direction am I traveling? Okay, so this is the problem on your handout. So we're going to go ahead and work on it with your groups, and then we'll come together and discuss what we found. So Brittany is driving west at 45 miles per hour. What's her velocity? What's the magnitude? What's the direction? And then draw a little arrow for what that is. At this point, I would be walking around helping students, but there aren't any, so I'm not going to. All right, so what did you guys get for the magnitude of the velocity? John, what did you get? 45 miles per hour, awesome. All right, that is how fast she's going. It's what we call the speed, right? Her speed is 45 miles per hour. But what is her direction? Brandon, what did your group come up with? What is the direction for her velocity? West, exactly. So now we know that she's going 45 miles per hour and the direction is west. So now we want to draw a little arrow to kind of show what direction she's going. So west, right, we have north, east, southwest, right? She's going west. So I'm going to draw an arrow going west. And we want to make sure that we label it with her speed. So the magnitude of this arrow, we have the direction is west, the magnitude is 45 miles per hour. Oops. So I have that arrow pointing down, right? What direction would that have been? South, right, good job. Okay. So if I told you that I was traveling 25 miles per hour southwest, which of those drawings would be right? Brandon, what do you think? Right, we can't really tell. All of those are going southwest. I didn't tell you how much more south than west I'm going. So what would help us come up with a better picture? How can we be more descriptive? What other information do we need? Right, an angle. Some kind of an angle, somehow, some kind of an amount more south than west, something like that would be really helpful. So we're going to start with this arrow. We know that we're going southwest, and let's see if we can come up with a good system to really, really well describe the direction that this arrow is going. Okay, so we have our arrow. Well, what would be helpful for us? Right, some kind of a label for what direction system we're using. Okay, awesome. What else could be helpful? It's still kind of ambiguous on how much more south than west we're going. Okay, some kind of a grid system, some kind of a coordinate system, right? That would kind of help us. Now we can see, am I closer towards the south end? Am I closer towards the west end? Okay. There's one more piece of information that may be really helpful to us. What do you guys think? All right, some kind of an angle. If I knew the angle between the direction that I'm going and the west, the horizontal line, then that would tell me exactly which direction I'm traveling. So you probably learned about this in your trigonometry class. We're going to review it again really quick. So you probably heard this phrase before, SOHCAHTOA. So the first part of that is the sine part. So sine equals opposite over hypotenuse. So this O for opposite right there, SOHCAHTOA. Okay, and then the next one, ka, that's the cosine part where we have the adjacent over hypotenuse. So let's go ahead and draw out a couple of these. Okay, so we have our triangle, and it has to be a right triangle, right? So here's my angle. So here's the opposite side to that angle. Here's the adjacent side to that angle. And then here's the hypotenuse of our triangle. So sine of theta, the sine of this angle, is the opposite side divided by the hypotenuse. The cosine is the adjacent side divided by the hypotenuse. Okay, and then the last one is tangent, where we take the opposite side and then divide it by the adjacent side. Okay, really quick, what do you notice? What are some of the similarities between these three? Alright, we have the opposite and the adjacent are both in those sine and cosine and in the tangent. And then the sine and cosine have a hypotenuse, but the tangent doesn't. So what if we took, let's kind of try and get rid of the hypotenuse. What if we took the sine and divided it by the cosine? So we're going to take opposite over hypotenuse. Okay, so I'm taking the sine, and then I'm going to divide that by adjacent over hypotenuse. Adjacent over hypotenuse, right? So I have the cosine part over, or the sine part over the cosine part. Well, that's the same thing as saying opposite over hypotenuse. Take the top part, our numerator, and instead I can multiply by the inverse of the denominator. So I'm going to multiply by h over a. Okay? Any questions so far? Okay. So now I'm going to just multiply it out just like normal. So now I have opposite times hypotenuse over hypotenuse times adjacent. Well, I have a hypotenuse on the top and on the bottom, so those pieces cancel. So all I have left is opposite over adjacent. Well, that's what we got for the tangent. So sine over cosine equals tangent. Pythagorean theorem, probably talked about this before in your math classes as well. It's pretty simple. It says, in my triangle, I have the two legs of the triangle and the hypotenuse. The A and B are the legs, and then C, that's our hypotenuse because it's directly across from our right angle. And if I take the square of A and the square of B and add those together, then I get the square of C. So we're going to do a couple of sample example problems. These are on your handout. So here's the first one. We have a building 50 meters away from the shore, and the building is 20 meters tall. I want to build a zip line from the top of my building over to the shore. So how long does the zip line need to be? Here's our Pythagorean theorem. So you use that, and we want to calculate how long does the zip line need to be. So we'll go ahead and work on that with your groups, and we'll come together and see if we can get the right answer. See if we can all get the same answer. All right, so what did you guys get? Jordan, what did your group get? Okay, awesome. Did you guys all get the same answer? Anybody else get something different? All right, looks good. We all got the same thing. Okay, here's our second example question. So we have second base is a certain distance away from first base, right? Or from the home plate. So we've got second base is 127 feet from home plate, and it's 90 feet away from first base. So we want to know this part of the triangle. That's the piece that we have left that we don't know. So we use the same thing, our Pythagorean theorem. I'm going to write it up on the board for you. So a squared, that's one of the legs, right? Plus b squared, that's the other one of the legs of your triangle, equals your hypotenuse squared. That's your c squared. Okay? So what did you guys get for the first part? How far away is first base from home plate? right? 90 feet, exactly. So does that seem kind of surprising? We have 90 feet from second base to first base, and we have 90 feet from first base to home plate. So that's kind of interesting. Well, can we calculate? We can calculate the line going from home plate to second base, and we can count the angle. We can calculate the angle between that line and this line. So how do we do that? Which one of our trigonometric functions are we going to use? We have sine, cosine, and tangent. Which one are we going to use? What do you guys think? Right, we could use cosine. What else could we use? We could also use sine. Right, it really doesn't matter. As long as you have two of the pieces of information. So tangent, if we were to use the tangent of this, we need to know the angle here, right? And we know opposite, and we know adjacent, and now we also know the hypotenuse. So we know all three pieces of the triangle. So really, it doesn't matter which one you want to use, whichever one. So if I want to use, let's say we're going to use tangent. So tangent of the angle equals the opposite. Well, what is the length of the opposite side? Right, 90. What about the adjacent side? Right, it's also 90. Okay, but I want the angle, I don't want the tangent of the angle. So what we do is you take the inverse of both sides. So basically we're going to take the inverse tangent of the tangent, and then the inverse tangent, so that's that -1, that's just the inverse part, of 90 over 90. Okay, so if I take the inverse tangent of the tangent, that part just goes away. So we just have the angle equals the inverse tangent. 90 over 90. Okay, so go ahead and plug in your calculators. Make sure that you are in degree mode. If you need help making sure that you're in degree mode, let me know. Okay, so what angle did you guys get? 45 degrees. Right, that's what's so special about a 45-degree triangle. If we have 45 degrees and 90 degrees, that means that one, the top one also has to be 45 degrees, right? Because the total angles in our triangle is 180. And for 45 triangle, 45 triangle is what we call it, then our legs are the same size. So, kind of interesting to know. Okay, so we're going to do our lab, but really quick before then, we're going to talk a little bit about the components of a vector. So here we've talked a lot about the angles and stuff like that, so we're going to talk about the components really quick. Okay, so we have our, let's just pick a vector, say this vector, okay? And we talked about how we want to be able to describe this vector really well. So we can talk about this angle, right, from the horizontal line. So we're going to call this our x-axis, right? You guys have talked about that in your math classes, your coordinate systems. And this vector has components both in the x and y direction, right? I could take this vector and I can divide it up into smaller pieces. I have a piece that goes over here, and I have a piece that goes over here. And if you add these two together, this is what you get. So when you're adding vectors, you draw your first vector, and then you take the second vector and put it tip to tail. And you put those next to each other, just like that. And then the line that you draw from start to finish, that's the sum of those two vectors. So let's kind of look at this a little bit differently. So here's my coordinate system. We have the green lines and the red lines. And I can take a vector, and I can put it at any one of these angles, right? And I can see here how much of this vector, how much of my little purple vector is in the red direction. Johnny, how much is in the red direction? None, right? We're only in the green directions. That means that this vector only has components in the green direction. Okay, what if I put it over here? Now, what direction is my vector? Right, it's only horizontal. But if I do go anywhere here in between, now I have components in each direction. So we're going to explore that a little bit more in the lab. So go ahead and, you guys have your groups assigned already, and go ahead and work on that. I'm going to walk around and help you guys out if you have any questions.